Okay, so for section 6.2, they start out by telling you 4 special theorems, and all of them are all about proving that a quadrilateral really is a parallelogram. First, they say that if you have a quadrilateral where it has 2 sets of opposite sides that are congruent, then it must be a parallelogram. If you have a quadrilateral that has 1 set of opposite sides that are congruent and parallel, then that's going to have to be a parallelogram. If you have opposite angles, 2 sets of opposite angles that are congruent, then it's a parallelogram. And if you have diagonals of your quadrilateral that bisect each other, then that has to be a parallelogram. These are the only 4 that will prove it to be a parallelogram. Doesn't say what kind of parallelogram it'll be. It can be any kind of parallelogram. It could be a square, rectangle, rhombus, or any other kind of parallelogram that we have, but it will be a parallelogram. So there you go. Which leads us to the classwork and homework. Hold that thought. Okay, so this is the classwork and the homework for this section. The classwork and the homework is not exactly easy, so I wanted to make sure I went over it with you instead of you struggling a lot, but I did want you to attempt it. So this is how it's going to run. For the classwork, basically it goes like this. You read it, you see if it will give you a parallelogram, not could you get one out of it, because you can always get one. But does it have to be a parallelogram because of the information they give you? And if it does have to be a parallelogram, then great, you say yes. And if it doesn't have to be a parallelogram, then you have to give a drawing of the figure that would be true that is not a parallelogram. Okay, so for number 1, they want to know if 2 angles of the quadrilateral are congruent. So can I draw a quadrilateral that has 2 angles congruent that is not a parallelogram? Well, sure can. If I draw this trapezoid, it has 2 angles congruent, and it is not a parallelogram. It only has 1 pair of parallel sides. So this one is a no. The next one says all pairs of consecutive angles are congruent. All the pairs of consecutive angles are congruent. Well, if all the pairs are congruent, that means they're all going to have to be 90 degrees, because we have to have a total of 360 degrees in our rectangle or in our quadrilateral, because 4, which is our n, minus 2 is 2 times 180 gives us 360. So these all have to add up to 360. And if they're all going to be congruent, that means that they're all 90 degrees. And if that happens, then we have opposite angles that are congruent. And if opposite angles are congruent, since all consecutive angles are congruent, if opposite angles are congruent, that means that it has to be a parallelogram. So this one is yes. Technically, it's a rectangle. Thought I'd throw that one out there. The diagonals of the quadrilateral are congruent. Can we draw diagonals in a quadrilateral that are congruent without it being a parallelogram? Well, if I had a trapezoid like this, technically it's called an isosceles trapezoid, then yes, my diagonals are congruent, but not a parallelogram. So this one is no. That's not proof. one pair of sides of the quadrilateral is parallel, and one pair of opposite angles is congruent. I've got lots of parallel sides going on, so I think I'm going to start with that. My sides are parallel. See, I tried to draw it without it, but my opposite angles are congruent. So if this one's going to be a big angle, that means this one has to be a big angle. So it does end up being a parallelogram. Oops. Go to right, yes. That's enough proof. Because of this parallel part, so when you have one that's parallel, and they give you opposite angles congruent, that means that we're going to end up with some other parallel and opposite angles congruent. Over here are the following, oh, sorry, that was the classwork. Guys, get right on over to that. This is the homework. All of 4 problems. I'm going to give you the answers to these 2, so you can go ahead and pause the video, and then I'll throw up the answers, and you'll be okay. Okay. Go ahead and get it over with all at one time. I'm just saying. Heck, the TARDIS blue. Are the following proofs that the quadrilateral is a parallelogram? 2 pairs of consecutive angles of the quadrilateral are supplementary. 2 pairs. 2 pairs. Let's see. If I let this angle be 100 degrees, that means that this angle would be 80 degrees, and it looks smaller. That one. 2 pairs of consecutive angles that's 1 pair. Suppose I could let my other pair be up here, 180. I think that works. Don't think it was supposed to work. But nobody said that it's 2 pairs of the consecutive angles. That's a consecutive angle, and that's a consecutive angle, and that's 2 pairs. Didn't say that they had to be consecutive to each other, which is what they really meant. But it's not what they said, so I'm saying that'll work. So I'm saying no. Now, if we had 3 pairs, then it would be a yes. It's probably what they should have said. 1 pair of the opposite sides are congruent, and the other pair is parallel. Parallel. And then these are congruent. So maybe that one goes in, and this one can go out, or we'll let it go in too. That's a no. Back to this kind of thing. They're congruent and they're parallel, but it doesn't work. The diagonal of the quadrilateral will separate it into 2 congruent triangles. Ooh, this one's trying to be tricky. The answer is no. I know because I saw the answer. But the picture for it looks like this. That's the diagonal, and these are the 2 congruent triangles. They were trying to be tricky there. That's why I went ahead and just threw that one out there for you. And then for number 4, the quadrilateral has 1 pair of parallel sides and one of its diagonals bisects the other diagonal. Well, that doesn't happen here. But two sets of parallel sides, yeah, has one set of parallel sides, and one of its diagonals bisects the other one. If that one bisects that one, that gives me a congruent triangle up here. Hold that thought. Obviously, not a parallelogram. That's one diagonal. And we can say that it bisects that one. But they don't have parallel sides. I don't have any set of parallel sides. When I go to make this parallel, when I stretch it out to make it parallel with that one right there, then its diagonal comes up here and it no longer bisects. In order for it to bisect, we have to stretch them both out. Which makes it look more like that, which is parallelogram. So that one's yes. Now I could give you homework in this, but I figured you didn't want to do any proofs. So no homework in this section other than with the 4 problems that we just did. And we are done with section 6.2. I'd rather you have the information than would you have to be able to use it. Isn't that odd? Okay, bye.